You're looking at a video of the Verona tornado. It occurred on this date in the year 2007. It started just north of Verona and tracked to the northeast. And this is a perfect example of a tornado that can occur in the so-called off-season. You can certainly get severe weather and tornadoes in October or even the middle of winter. So please, if you're thinking that can happen, stop that thinking. Let's break down exactly how this tornado occurred. Let's take a look at the setup for this particular tornado and others that occurred in the state of Missouri that same day. Here is the Storm Prediction Center outlooks for that morning, issued at 7 a.m. And this shows a moderate risk of severe thunderstorms encompassing all of southwest Missouri. Good chunk of Arkansas, Oklahoma, Kansas included in that too. Slight risk, pretty large, again, considering the time of year. And also, specifically, the tornado threat, there was a 15% tornado risk. That's that dark blue area right there. Again, pretty high for this time of year. It's, what that means physically is a 15% chance of a tornado occurring within 25 miles of any point you pick, your town, your house. So pretty high for the time of year. And if we look at the 300 millibar map, I don't show this too often in a lot of my other videos, but this is maybe considered more the traditional jet stream level. It's at the top of the troposphere where all the weather occurs. These are going to be the winds roughly at the, or at least closer to the top of a thunderstorm. And what it shows is a classic negatively tilted trough. So it's a trough of low pressure that tilts from northwest to southeast. And with the higher winds coming in around the base of that, that just means this is encouraged to deepen and it encourages wide scale rising motion out ahead of the trough, which generally speaking destabilizes the atmosphere. All else equal, if you've got that being applied, it's going to make it more unstable with time. But also significantly for this day, we had this little tiny jet streak right here. And it's also been shown by research that this area right here is another preferred area, kind of layered on top of the larger scale one where rising motion is encouraged. So you put those two factors together and we had an atmosphere that was probably going to destabilize fairly rapidly that afternoon. It was sunny, so that we had that going for us, and I'll show you some other things that were going on as well. If we take a look at the 500 millibar map, that's something I show a lot more often. It's in the middle of the troposphere, so it's a kind of a good average, still a negatively tilted trough. Maybe a little short wave in here, kind of hard to tell, but the overall wind field, you were talking about 50-knot winds all throughout this area here to a rough approximation. And note that the wind direction that's indicated by how this line is drawn is out of the south, and not really southwest, almost southwest, kind of between southwest and south-southwest. So make a note of that, because if I show you the winds that morning at the surface here in Springfield, they're out of the southeast or south-southeast. So if the upper level winds are like this and the lower level winds are like this, there's a net rotation this way in the lower part of the atmosphere. That's encouraging of a potential rotation of thunderstorms. It really does. And furthermore, not just the overall rotation of the storm itself, but could actually have implications for the lowest level rotation, which is what a tornado feeds upon. And there are signs of that, certainly. So if you look at the station models, these are just shorthand. So the way you read this, here's Springfield. So the red is the temperature, the green's the dew point. The rest of those are pressure values, not really much significance here. But we had wind gusts to 25 knots out of the southeast in Springfield at 7 a.m. Dew points were in the upper 50s across this area right here. By 4 p.m., right before tornado production, we had our dew point had jumped to 66 degrees. Winds still out of a favorable direction. It just encourages low-level rotation. And the dew point depression, the difference between the temperature and the actual dew point, is 6 degrees. So research has also shown that low-level dew point depressions, 10 degrees or less, some say 6 degrees or less, is what it does is it lowers the base of the thunderstorm. And when you do that, it means that the thunderstorm reaches its visibility level, the moisture actually condenses into what it's actually physically you see as a thunderstorm is a lower base. So if there is any low-level rotation, that storm can more easily tap into it the lower that base is. So let's take a look at what had happened here. This is a radar at 4:30, so a huge squall line from Iowa all the way down to southeast Kansas. A lone supercell in a tornado watch area. That's this here. I highlighted the one that affects us, but there's also one in effect here and here. And so it was a pretty prolific day for tornado production, or at least potential for it. If we look at the tornado archive here, we're seeing there were more tornadoes than just these three in southwest Missouri. Another brief one there, and these are pretty significant too, including the strongest tornado of this little mini outbreak of that day, which was an EF 2, which actually did cause some fatalities. So we have the Verona-Aurora tornado, which was an EF0. There's some controversy in the data, by the way, but I do think it's EF0. A lot of times it's called the Verona or the Aurora tornado, but actually, according to the official record, it was 2 miles north of Verona, roughly. So it's actually referred to as the Verona tornado. We had another one, same storm in Cave Spring, northwest Greene County, and a brief one there in Laclede County as well. Here's a radar loop of that day, and I'm just focusing on the Verona tornado. And you can see it started there in extreme northeastern parts of McDonald County. And then you can see the purple are the various funnel cloud and tornado reports that occurred along its journey. It stops just short of producing that tornado in Cave Spring, but we'll show you still images here. So the initial trouble began at 4:21, tornado warning issued. This was a funnel cloud report around Wheaton. It was starting to show some low-level rotation. You can kind of see the hook developing there. This image is at 4:45. This is when the tornado was actually just ready to start. So remember, it was 2 miles north of Verona. So we're looking at the initiation time. At that point, it was just radar indicated. So the tornado warnings are in red. And that's significant because when I show you the next slide, once the report of that tornado came in north of Verona, then it ups the ante, so to speak, for the tornado warning. And the purple indicates it's a tornado warning based on an actual report, not radar indicated. So that's a important distinction. Both should be taken seriously, but this one is more serious because we actually have verification on the ground that something happened. So here's the plot of the tornado, and this is what I'm talking about. There are various databases out there that record tornado intensity and description. This one is listed. It's funny because in this description here, it's an EF2, but in the actual database I pulled this out of and got this from, it's listed in the column as an EF0, and everything else I've seen is an EF0, and even the damage probably suggests that it was. So I'm not sure why that's in the record. I may have to contact somebody about that. But there's where it tracked, basically. So it's just kind of west of Aurora, northwest of Aurora, and Verona is actually right there. So that tornado was pretty significant, damaged some homes, and a dairy barn and a sawmill. So this tornado kept going. Funnel cloud report in Halltown. I should say the storm kept going. The tornado stopped for a minute. That is at 6:14. And then at this time needs to be updated. This is at 6:34. I apologize for that. That should be a 3 and a 4 right there. I missed a 1 and replaced it with a 3 and replaced it with a 1. Sorry about that. That's 6:34. And then Cave Springs. This is again right as that tornado was developing up in that part of Greene County. Here's the stats on that. An EF1 tornado touchdown 1 mile northwest of Cave Springs. About 3 miles on the ground through northwest Greene County, 2 homes and a barn damaged. So again, like with most tornadoes, these could have been a lot worse depending on exactly what they hit. They were certainly strong enough to do more damage and cause more injuries and deaths potentially. So pretty significant. Then we had this brief tornado here, EF0 tornado in southern Laclede County, damaged some telephone poles there halfway between, let's say, Phillipsburg and this unincorporated area of Evergreen. Then I want to also talk about later on, this storm here was an EF2, and it did produce some fatalities. This is in Monroe County. So here's Columbia, Missouri, Jefferson City area. So kind of northeast of that area later on in the evening. It did cause a more significant EF2 tornado, which unfortunately did throw 2 people from a mobile home and killed both of them, unfortunately. I'll just close this video by showing the Verona-Aurora tornado in its entirety. I've shown you clips up to this point. I hope you enjoyed this sort of thing. I'll try to do this more in the future, a review of significant events in Southwest Missouri.